As a developer, dealing with exceptions and knowing which one to catch is one of the trickiest parts of writing reliable code. So how do you tackle this problem? Take this piece of code right here. We have an employee variable that stores a dictionary, a collection of key-value pairs. We have a key called name with the value James. Further down the code, we try to print the employee's salary. Now, of course, salary doesn't exist as a key, because if it did, it would look something like this. You would have salary as a key, a colon, and then the salary value, that would be James's salary right there. Run it like that, and the code works fine. But without it, how do you figure out which exception to catch? And how do you handle these errors properly? If I run this code now, you can see we get a key error. That right there is the exception type. And the error message tells us the key is salary, because Python is looking for that salary key and failing. My best advice, and this is exactly how I do it, wrap your code in a try block. This is the code that has the potential to throw an error. Then in the except clause, catch all exceptions by using the top-level exception base class. This is the root of all exception classes. Every other exception in Python is a child of this class. Store that caught exception in a variable, then check the type of the exception that actually triggered. Run this, and you can see the class is key error. That is the exception type, and the key is salary. Now you can add another except clause right below this one. Copy that exception type and paste it in there. That handler is for key error, and now we can catch it specifically. Then we print a very targeted message to say the key does not exist. That message is tied directly to the key error. With this in place, the generic exception handler will no longer fire. Run the code again, and you get the key does not exist message. Instead of trying to figure out the error type on the fly, ideally, you should not leave debug handlers in production. But if you do, make sure you have a clean and graceful exit strategy. Always be precise and deliberate with your error. Handling, catch the specific exception type you expect. To find that type, you have two approaches. The first is the straightforward way. Simply run the code and observe what type of error it throws back at you, like key error. Or second, print the type of the exception object you captured here. Print the type of the error and see exactly what you're dealing with. How do you build an error handler for this one simple line of code? Right here, this line is trying to print a variable. And if I hover over it, you can see visual. Studio Code is flagging it, saying my variable is not defined. Run this code and you immediately get more information. The error we get back is a name error. It says the name my variable is not defined. So how do you build a proper error handler for this? Or better yet, how do you identify this error without letting it crash your program in this raw, unhandled fashion? First, let's clear the output by clicking this button. Now we will wrap our code in a try and except block. We write try followed by a colon and place the risky code inside. Then we add the except clause below. When the error occurs, we simply want to print a clean message to say an error has occurred. And now we have that message ready. Run the code and you can already see a clear improvement. No more ugly and intimidating error output. Instead, the user sees a clean message, an error has occurred. Now, to catch this specific error, we need to find out its type. We know an error happened, that much is clear, but when we hover over it in Visual Studio Code, it says, my variable is not defined. That's not specific enough. So how do you capture that exact error type? We'll add another print statement right after this message. Using print, we will output the type of this error object. To capture the error, we update the except clause to catch and store the exception object right here. We use exception, which is a class name. Notice the capital E. Hover over it, and Visual Studio confirms it is indeed an exception class. We are now capturing that error as a variable, and then we can print the type of that error. So we clear the print statement and use the type function, passing in the error variable to reveal its type. When the error fires, it gets stored in that variable automatically. Whatever the error is, that object, and remember everything is an object. In Python, that object gets captured here, and we can inspect its type. Run the code now, and we have a significant improvement. We can now see the error type is name error. Look at what Visual Studio Code says up there. It says not defined. It does not tell you the error type, but our code just did. Now we know exactly what we are dealing with, name error. We can now be very precise, and instead of catching a generic exception, we will target a specific named exception. So we add another except clause and simply Copy that name error and paste it in with a colon. Now we write a precise message tailored to this exact error. We'll say variable does not exist. Run the code now, and we get that precise targeted error, the name error, which says variable does not exist. This is the technique I use regularly to identify the specific type of error, so I can handle it correctly inside the try and except block. I always prioritize the specific handler. Now, pay attention here. I have the specific handler up top, but if I move it down and place it below the generic one, you will see that the generic except clause grabs the error before it even reaches the specific one. But if I cut that and move it back to the top before the generic one, now because the specific handler comes first, we see the specific error being caught right here. Always go from specific to generic. When you're just starting out with Python, you probably end up doing this whenever you need to concatenate strings. Here we have a user called Sarah, and she has 12 tasks. If you want to print something like user Sarah has 12 tasks, you probably reach for the plus symbol. In some languages, it is the ampersand, but in Python, we use plus to join strings. So you end up doing this a string here, then a variable, then another string, and then another variable, chaining them together. And because tasks is a number, you have to convert it into a string first so you can concatenate everything cleanly. The end result is this nicely formatted output. User Sarah has 12 tasks. But this is hard work, and it is hard work because Python gives us a much better alternative. You can simply do this. You still start with your print statement as usual. Those yellow parentheses mark the start and end, but inside you write the whole string as one with curly braces as placeholders, what I like to call curly brackets. Then you have has task. And notice there is only one opening quote and one closing quote for the entire string. At the end of that string, you call .format and pass in the values that fill those placeholders. Those curly braces are your placeholders. And in order, they get filled starting with the first one. So username, which is Sarah, fills the first placeholder, and tasks fills the second placeholder here. These are the variables I am passing in. And the result is exactly this. User Sarah has 12 tasks. Now notice something important. With tasks, in the old approach using concatenation, we had to manually convert that integer to a string before joining it. But with .format, we just pass the variable in directly. No conversion needed because the format function handles that for us and automatically converts it to a string. So you never have to do that manual conversion yourself. Behind the scenes, it does call the str method if the value is not already a string. So the same work is happening either way, but the code is so much cleaner. And you never fall into that trap of, oh, I forgot to convert my integer to a string. I hope you found this valuable. If you did, like, comment, and subscribe, and make sure you adopt this cleaner approach. It is not a big change at all. Just write your entire string with curly brace placeholders, call the format method, and pass in your variables instead of this messy approach. Look at how many times you repeat the plus symbol, plus here, and you simply do not need any of that with string formatting, and this is what is known as Python string formatting. Someone asked a great question. How do I use the string format method to display a currency price? Here we have a variable called product laptop, and the price is $1,299. So how do we use that to print out, say, the pound symbol, or any currency symbol displayed right alongside the price? Simple. Here is your string. Normally, you might join it all together using plus symbols for concatenation. With string format, you just use placeholders. Your entire string lives inside double quotation marks. And wherever a value goes, you drop in a curly brace placeholder. What we want to say is laptop costs a certain amount. So right now it outputs laptop costs $1,299. But the issue is we want the $ or pound symbol or whatever currency you are working with to actually appear. If you try dropping the pound symbol inside the placeholder itself, it will not work. And the code will error. Instead, place the pound symbol just outside, right before the second placeholder, since that is where the price will be inserted. Place it right there. That is your pound symbol. And now look at the output. Laptop costs a certain number of pounds, and you can swap it to a $ or any symbol you need. You could even store the currency symbol in a variable. So here, you could have a currency variable and bring that in dynamically at runtime. Then you have that covered too. Another placeholder for the currency. and then you shift the order slightly because that is placeholder 1 and price is placeholder 2. So you simply add the currency variable in here as well. And now your code is flexible. You can switch from dollar to pound with just one small change. So if you want to say the amount is $12.99, 99 cents, you just drop that in here, and there you go. You now have $12.99 displayed. And the price is formatted correctly. You do not need to convert anything because this is a float. You do not need to manually convert it to a string. The format function handles that automatically, converting your variables to strings for you. So you never have to wrap your variable in stir just to plug it into a string. That extra step is completely gone. Just leave it as a variable name and let the format function do the heavy lifting. Your code stays clean, readable, and easy to follow. So to recap, that is exactly how you display a currency symbol, using Python string formatting and the format function. Order absolutely matters in string formatting. When you have placeholders in your string and you call the format function, passing in variables to fill them, each placeholder is matched by position. The first placeholder on the left gets the first value, moving left to right. So the first argument maps to the first placeholder on the left, then the second argument maps to the second placeholder, and so on. It flows strictly from left to right. Left side of the arguments maps to left side of the placeholders. That is how the values slot in. So the name James goes into the first placeholder because it is first in the format call, and Sarah goes into the second placeholder, and you can easily swap them around. Right now it says James greeted Sarah. Swap the order and you get a completely different result. Put Sarah's variable first and James's variable second. And right now, it still shows James greeted Sarah. But run it, and now we get Sarah greeted James. Completely the opposite. And that is exactly why the position matters. So always make sure you match the correct placeholder with the correct position of its variable inside the format function. Here is another powerful concept to understand about string formatting in Python using the format function. Write your string in double quotes and you can drop index-based placeholders inside to inject variables precisely. For example, we can say developer is Emma, and when we run this code, here's the output we get. Emma reviewed code written by Emma. And what is fascinating about this is that in the first placeholder, we only have a 0. You can refer to placeholders by their index. So 0 and 0 again, both are the same index. So when you pass a variable in, it sits at position 0 and it fills every placeholder that also references index 0. So you can reuse the same variable as many times as you need just by referencing its index number. And you can do this as many times as you like. You could place index 0, 3, 4, or more times anywhere in the string. The same rule applies here. You can see here we have the second argument appearing first and the first argument appearing second. We have deliberately swapped the order, and yet the output reads, API sends data to the database. So API goes to the first slot, right? And notice that placeholder is referencing index 1, which is the second argument passed, and database goes to the second slot, referencing index 0, the first argument. I swapped them intentionally to show you that placeholders are independent of the variable names, but the index position you specify is what drives the output. Whichever index you specify in the placeholder, that is what gets placed there. The variable names do not matter. So you could call the variables API and database for clarity, then pass them into the format call as API and database. And this time the output flips. Database sends data to the API. Now I can swap the order again. I want index 0, which is API, to send data to the database. So the placeholder at index 0 maps to API, and the output is now API sends data to database, or I swap it to index 1, then index 0 over here. And that gives us database sends data to API. These are positional placeholders. The index you use inside the braces corresponds to the position of the argument in the format call. And you can use any index as many times as you want. So if you want to repeat a value, for example like this, you can reference index 1 again, and the word database appears twice. But if you reference an index that does not exist, like index 2 when you only have 2 arguments, you will get an index error saying you are referencing a position that does not exist. Index 0 is the first argument, index 1 is the second argument, and index 2 simply does not exist. Rather than juggling positional index numbers inside your placeholders, and trying to remember which number maps to which value, we have a standard string where the dynamic parts are injected from this section right here, which is the dot format function called directly on the string. This is the string, and dot format belongs to that string. We are passing in positional arguments, which then get slotted into the placeholders. But instead of that, you can go one step further and use named parameters. So take a look at this string over here. Specifically, this part, employee completed a number of tickets today. The values are being injected by dot format, and you can see that employee is set equal to the employee variable, which holds the name Emma, and that gets placed right into this placeholder. And then tickets is set to the hard-coded value of 18. So you can pass hard-coded values directly inside the format call and use named arguments. Just like that, those named arguments act like parameters and map directly into the matching named placeholders inside the string. No guessing positions, no counting indexes. This approach is far cleaner, and honestly, this is the way I prefer it, unless you have a specific situation where positional indexes make more sense. Both are completely valid. It just comes down to your preference. Which one do you prefer? Run this code, and you can see it outputs Emma, which is coming from the variable passed in via this named argument into this placeholder, completed 18 tickets today. 18 is hard-coded, not from a variable. And you absolutely can do it that way. I could have just typed Emma directly here. Notice this Emma is lowercase, while that one is uppercase, but you can simply point it to a variable instead. Both techniques are powerful, each with its place. And this one works just as well. You can see the first position here, which is that index API maps to API sends data to the database, which is at position 0. Position 0 is the second variable here, which is assigned the value database. So the output is API sends data to database. Let's break down this syntax right here and understand how to format numbers. This is a situation you will encounter very often. You have a temperature value here, and it has way too many decimal places. You only want to display 2 decimal places to the user. So how do you solve this elegantly? Let's get the fundamentals in place first. Here's our string, and we have a placeholder sitting inside it. Let's start with the most basic version of this. So if we simply do this, I will comment out that line and show you the step-by-step. Let me strip that back to make things easier to follow, so you can clearly see what is going on. Temperature here is a placeholder, specifically a named placeholder. And this here is the format function. This is a pattern you will see all the time in real code, and then you have temperature set equal to temperature. So I have called this placeholder temperature, and the format function maps to that placeholder. So I'm targeting the temperature placeholder, and the actual value for it comes from the variable called temperature. So this temperature on the left is different to the one on the right. This one on the left names the placeholder. The one on the right is setting that placeholder equal to a variable. To make the distinction clearer, I could rename the placeholder to temp, and you can see the difference instantly. So temp is the placeholder name, and it is mapped to the temperature variable. Run this, and you can see we get the value 21 point something with all the decimal places intact. Now, let's keep this line visible and build on top of it to show you exactly how the formatting syntax works. Now we want to format that number to 2 decimal places. To do that, you add a colon right inside the placeholder, and then specify how many decimal places you want. So you put a dot and then a 2. That means 2 decimal places after the decimal point, and the number we are working with is a floating point number. Now watch what happens when you run this without adding an F at the end. It switches to scientific notation. That is not what we want. So add an F in there, and that locks it to the correct decimal format, 21.68. That is how you display a decimal to a specific number of decimal places using string formatting. Now this code we started with, remember, it began like this. You had temperature as the placeholder name. Then you wanted to format it, so you added a colon inside the placeholder and specified 2 decimal places after the dot, but that gave you a scientific notation number. What you actually wanted was a decimal, so you added an F, and there it is, exactly the output you were looking for. I hope that all makes sense. And I know the part that looks confusing is when temperature is mapped to temperature, and you think, wait, what is going on? Totally understandable. I did that deliberately so you could see exactly how the mapping works. You will often see developers drop the variable name entirely. And when they do, the code looks like this. Let me comment this line out so you can see both. There it is right there. It simply passes in temperature directly from this variable, and the placeholder is left blank with no name. Unnamed placeholder, but the code still works perfectly. Click run and we still get the same output. To make it distinct, I'll swap in a different temperature value, 31. And yes, it works as expected. This is what you will commonly see in the wild, but all it is missing is the named placeholder. Check out my earlier videos if any of this is unclear, because those earlier lessons are where the foundation for all of this was built. Hopefully it all clicks now. It is actually quite straightforward once you see the pattern clearly. Just compare these two examples and it will all make perfect sense. Do you know what this syntax is doing in Python? If you do not fully grasp string formatting, you will genuinely struggle to read code like this. So here we have invoice total. Invoice total typically means currency. What we want to do is display that invoice total in pounds, formatted to 2 decimal places. Run this code and the output is cleanly formatted right there. Let's walk through it step by step. Here is the full string, and inside it we have a placeholder. Let's start from scratch. If I just drop in a basic placeholder and run it, you can see we get the full raw number, 1875.456, but we only want 2 decimal places. So add a colon inside the placeholder, then a dot to indicate you're targeting the decimal point, and after that dot you specify 2 decimal places. Run it, and now we get a scientific notation number. That is not what we want. We want a decimal, so we add an F. In Python, F stands for float, which gives you a decimal, and now we get a beautifully formatted decimal string. Now you might be wondering, what exactly is the colon doing? The colon essentially separates the variable name from the format spec. The variable comes from here and gets placed into this placeholder. If you had a named placeholder, that probably makes sense now. This is a named placeholder. You can leave the name out entirely and just leave it blank. Or if you use a name, the format function maps to it exactly as before. Run this code and you will see it throws an error. I did that deliberately because it is looking for a named parameter. So you need to supply the name invoice total. Total is the named parameter, and it maps to the variable invoice total. Now I can rename it something different just to make the distinction clear. Let's call it invoice. Now when I do this, you can see it is looking for invoice total, but I have called it invoice. So I copy that name and paste it in, and that resolves it perfectly. And now you can see it works. So by removing the name from the placeholder, you're just taking a shortcut. You are not assigning a name. You're passing the variable in positionally, and you get this output. Now you can apply the same logic to the thousands separator. To add a thousands separator, add a comma right after the colon, and that automatically inserts the thousands separator into your number. You can also apply the same technique for percentage formatting. The same logic applies. You have a number, and you want to express it as a percentage. So you put a dot and specify 1 decimal place after the decimal point, and then format it as a percentage using the percent symbol. Without it, you would see something like 0.9, not a percentage, but with the percent sign, Python multiplies by 100 and gives you 94.8%. I hope this clears things up and removes that confusion people often have with this syntax and why it works this way.